Fine. So I did not record, okay, but this is how it is. So answer is 1.18. What did we do? Again, I will tell you. Here is a heat transfer part. Here is a heat transfer part. You calculate what is the temperature on the other side of the slab. On this side of the slab is 80. You have Q transferred, which is equal to 4.5 kilowatt per meter square. And then here you have to find the temperature because K is given, the thickness is given as 0.1. Using this equation, we can find out the other temperature. We have done that, which is 50 degrees centigrade. We have found it. Once we get that as 50 degrees centigrade, then you use the temperature required. See here, ds. If dq is the same, ds will be higher on the lower side, lower on the higher side. So the difference gives the entropy generation. Heat transfer from the higher temperature to lower temperature leads to entropy generation. What is that? It is dq by T at lower temperature minus dq by T at higher temperature gives us delta S. That's what we have applied. Then Trishul got the answer, understood?
Yes, sir.
Trishul. No, wait a minute. Trishul is mute, I suppose. Yeah, Trishul, are you hearing me now?
Yes, sir. Yes, sir.
Yes, yes. I'm sorry. Okay. So I'm me asking it is important. I hope everybody has written now. Understood. Yes, yes, please. ಇದು ಖುಷಿ ಆಗ್ತದೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ತಗೊಂಡು ಹೋಗೋದ ಎಷ್ಟೋ ಜನ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಓದಲ್ಲ ರೀ ಅದೇ ಪ್ರಾಬ್ಲಮ್ ಅದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಓದಿದ ಕರೆಕ್ಟ್ ನಾಲೆಜ್ ಓದು ಅದಕ್ಕೆ ಕಷ್ಟ ಇದೆ ಹೋಗ್ತೇನೆ ನೋಟ್ಸ್ ಓದಿ ಅದರ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅನ್ನು ನೀವು ಡೌಟ್ ಕ್ಲಿಯರೆನ್ಸಿಗೆ ನೋಡಿ ಆಯ್ತಾ ನಿಮ್ಗೆ ಹೇಗೆ ಅನ್ಸುತ್ತೋ ಹಾಗೆ ಸರಿ ಆಯ್ತಾ ನೆಕ್ಸ್ಟ್ ಹೋಗುವ ಇಲ್ಲ ಬರ್ದಾಗ್ಲಿಲ್ಲ ಆಗಲಿ ಆಗಲಿ ಆಯ್ತಾ? ಸರಿ, ಆಯ್ತಾ ಅಂತ ಹೇಳ್ಬೇಕು, ನಾನು ನಿಮಗೆ ಕಾಯ್ತಾ ಇದ್ದೇನೆ. ಆಯ್ತಾ, ಎಲ್ಲರೂ ಆಯ್ತಲ್ಲ? ಸರಿ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಹೀಟ್ ನೋಡು. ಇದಲ್ಲ, ಇದು ಕಂಟ್ರೋಲ್ ಎಫ್. ಸೇಮ್ ಹೀಟ್ ಕಂಟಿನ್ಯೂ ಮಾಡು. ಎಂಟ್ರೋಪಿ ಜನರೇಷನ್ ತನಕ ಬಂದ್ವಿ. ಓಕೆ, ರೀಹೀಟ್ ಬೇಡ, ಆಟೋ ಸೈಕಲ್ ಬೇಡ, ಇದು ಬೇಡ, ಓಪನ್ ಹಾರ್ಟ್ ಸರ್ಜರಿ ಆಯಿತು, ಹೀಟ್ ಆಯಿತು. ಸೊ ನೋ ಮೋರ್ ಕ್ವಶನ್ಸ್ ಐ ಸಪೋಸ್. This is all related to this one only, but not important now. It's in convection. A lot of questions have come in 2022. Let us look at 2021 now. It's very important to see all the things again and again. Okay. So 2021 gate we will see. 2021 mechanical engineering, control F and heat. I think we'll not be able to do it. Okay. So you have to see the paper full. Okay. So let us look at the paper and or let us do here. Okay. We have this. Is it not? We have, there is heat generation. So okay, 2021 ambient. Okay, this we can do ambient. Ambient, no we cannot. Okay, so it is come in set 2. Question number they don't put, so will not. Set 2, so we go to set 2 and let us look at it. If you see ambient somewhere, tell me students. It's 2 marks. Ambient pressure, no, not this. Ambient air, yes. This is a good question, students. Can you solve this? So this is a question which we have to answer. Now here it has purposefully it is one level higher, but still I think by the input I have given you, you will be able to solve this, students. This is gate 2021 set 2. This is 2021 set to 2 marks. So ambient flows, air flows over heated slab having a flat top surface at y is equal to 0. The local temperature profile within the thermal boundary layer is given. Thermal boundary layer is given, where y is the distance measured from the slab surface in meter. If the thermal conductivity of air is 1 and the slab is 100, then the magnitude of temperature gradient within the slab at y is equal to 0 is. Almost every question, every year you will have one question on this first chapter. I will not do anything. You tell me. Okay, let me put it. So we are not talking about thermal velocity boundary layer. We are talking about thermal boundary layer. Now here only consideration is, I have told you yesterday's. Yeah, you tell me, students, how can we solve it? Because it's about, you have to get the, it has to strike you, is it not? That idea has to be idea has to come. Why? Q is Q is minus Ka into dt by dy. T is given with respect to y. Differentiate, get the answer. Complicated looking, easy problem. Did not get it? Think. Go back, go back, go back. One person has got it, but you have to get it. Exactly. Nothing great. Yes. Yes, 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 yes. But dt by dy where? Not in the air. It is in the slab. Don't say Ty, I will differentiate, sir. I get the answer. No, 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 no. That is in the air. What is it in the slab? That you have to find out anyhow. But what is it in the slab? Hmm. Q is known. Exactly. Simple. See how simple it is when you understand the concepts. The people who have not got the answer means yes, they have not got the concept. Think, think, think. See the notes again. See the notes again. You'll get it. It's all based on Fourier law of heat conduction. What is Fourier law of heat conduction? Q is equal to minus Ka into dt by dx. That's it. And whatever the heat which is transferred from the slab goes to here. So conductivity is more means dt by dy will be less or more. Dt by dy will be less or more. Less, is it not? It's be like this. Here it will be like this. Correct. The slope here, see, temperature more would be here. I'm sorry, here like this. This will be more, this will be less. Temperature will almost be same. Or not like that. I will write this, say high temperature. So as it goes here, it goes low temperature. Then here it goes, but with the dt by dy will be more here because this would be the slope. And the conductivity is more, dt by dy will be less. Here dt, the temperature profile here, if you write, this would be the temperature profile here. On this side, this would be the temperature profile. Yes or no? No, no. Here temperature I'm increasing, is it not? Here it has to decrease. So other way around. I'm sorry. So temperature is more here. As it comes down, it decreases, and here it still decreases with a higher. This should be the temperature, and this being T infinite. If it is a hot plate, but we do not know whether it's hot plate, cold plate, a heated slab. It's given. Heated slab is given. ಏನಾಯ್ತು ಗೊತ್ತಾಗ್ಲಿಲ್ವಾ? 1000 ಬಂತಾ? ಬೇಗ ಮಾಡಿ ಅನ್ಸುತ್ತೆ ತಗೊಂಡು 10 ಬಂತಾ 10 ಕೆ 100 ಕೊಟ್ಟಿದ್ದಾರೆ. ನಾನಿಲ್ಲಿ ಸುಮ್ಮನೆ ಕೂತ್ಕೊಳ್ತೇನೆ ನೋಡು ಎಷ್ಟು ಜನಕ್ಕೆ ಬರ್ತದೆ. ತ್ರಿಶೂಲ್ ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir, doing.
Yes. Easy. Prashant answer the heat transfer is one of the easiest subjects. Looks difficult, intimidating. Huh? Yeah. Got it? Did not get it. Sujit did not get it. No. What about Chetan? No, you got the concept. Bharat got the concept. No. Okay. I'm worried about concept. Answer you get. You don't know the concept. Ah, you got the concept. I'll explain the concept. Observe here the students who did not get the concept. See here, the heat transfer is depend on minus Ka dt by dx. Temperature profile is given here, right? Since the temperature is profile is given, where the temperature profile is given? Inside the air. The air is coming here. The air temperature profile is given with y as a distance, right? So you get dt by dy is equal to here. You get dt by dy. Here it is not dt by dx, it's dt by dy because the temperature, the transfer, heat transfer is in the y direction. So dt by dy would be differentiation of this, which would be 200 into minus of 5, which is 1000, into e power minus 5y. And what is it at 0? dt by dy at 0. This is minus here, which dt by dy is minus, right? So it is minus 1000. Because y is equal to 0, you are applying e power 0 is 1. So that's it. Okay, this is minus 1000. Now applying this here, so heat transfer rate is equal to minus Ka. We will keep in 1 meter per meter rate. Minus, so plus 1000. So heat transfer is 1000 K, which is equal to 1000. K is given there. What is K there given? K is given as 1. So let us have 1. 1 into 1000. So what is the heat transfer rate? Heat transfer rate is 1000 watts per meter square. That would be the heat transfer rate. Now this heat transfer rate is in the air. The same heat transfer rate goes with the slab also. Since it is the same, Q is equal to, I'll write it. I understand, but still, I'll write Q is equal to K into dt by dy. Here, this is K, this is dt by dy. Fine. Next, on the other side over here, next, same Q will give us conductivity is 100 and is K into dt by dy in the slab. Fine. What is Q? Q is the same 1000 watt per meter square is equal to 100 into dt by dy of the slab. So what is dt by dy in the slab? It is equal to 10 watt per, sorry, Kelvin per meter. Is he now understood the concept? Everyone? That is why when people solve it, you think that it is very difficult. It's not difficult. Knack has to come. That's it. Gate is not a tough question paper. It's an easy question paper, provided you get a knack. It's not long at all at any point of time. If you know all the knack, you will complete the gate exam within 2.5 hours. 2.5 hours is more than enough. Exactly. Within the thermal wall. Why differentiate? Q is equal to, see, whatever heat transfer happens from the slab becomes the same thing through the air, is it not? The heat, the air which is cooling by the air which is coming. So the heat transfer rate, heat which is, where is the heat coming from? Slab. Where it is going to? air. So it's the same heat transfer which is going from the slab to the air. So heat transfer in the air as well as heat transfer in the slab is the same. Agreed? Right. Okay. I'll write it in another. See, heat transfer Q in the slab is equal to Q in the air. Agreed? So Q in the slab is what? Q in the slab is K of the slab into dt by dy of the slab. Agreed? Q in the air is equal to K of the air into dt by dy of the air. dt by dy of the air is equal to, and this slab is at y is equal to 0. This is also at y is equal to 0. It is not something else. Agreed? So what is dt by dy at y is equal to, this is d of dy of 300 plus 200 e power minus 5y for air. What is this? This comes out to be 1000. This comes out to be minus 1000 e power minus 5y. dt by dy air at y is equal to 0 is minus 1000. Correct? You apply this over here. K is given as, therefore what you will get, K is of the slab is 100 into dt by dy of the slab is equal to K of the air is 1 into dt by dy of the is minus 1000. Minus minus both side cancel, so minus and minus here, minus and minus cancel. Easy. Once you get the answer, it becomes easy. But the main point is whether you'll get that answer clicks you in the exam. That is important. With the exam pressures, that is important. From now onwards, you have to imagine that you are in that pressure. You'll get. Anytime I can explain you these things, there's no problem because these are basics. Next one. So don't get intimidated by seeing that it is just Fourier law of heat conduction. ಅಷ್ಟೊಂದು ದೊಡ್ಡ ದೊಡ್ಡ ಈಕ್ವೇಶನ್ ಎಲ್ಲ ನೋಡಬೇಕಾದ್ರೆ ಅಲ್ಲಿಂದ ದೂರ ಓಡ ಹೊಡ್ತೀರಾ, ಆ ಥರ ಮಾಡಬೇಡಿ. ಟೇಸೆಟ್ ಅದು ಹೇಳಲ್ಲ, ಯಾಕೆ ಹೇಳೋದಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಬೇಸಿಕ್ಸ್ ಇಂದ ಆಗ್ತದೆ ಅನ್ನೋದು ನಮಗೆ ತಲೆಗೆ ಹೋಗ್ಬೇಕು. ನಾನು ಕನ್ವೆಕ್ಷನ್ ಚಾಪ್ಟರ್ ನಂತರ ಇದು ಕೊಟ್ಟಿದ್ದಿದ್ರೆ ನಾನು, ನೀವು ಅನ್ಕೊಳ್ತಿದ್ರಿ ಯಾವುದೋ ಒಂದು ಇಕ್ವೇಶನ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು ಅಂತ ಅನ್ಕೊಳ್ತಿದ್ರಿ. ಇದು ಬೇಸಿಕ್ಸ್ ಅಂತ ಅರ್ಥ ಆಗ್ಬೇಕು ನಿಮ್ಗೆ. ಸಮ್ ಬೌಂಡ್ರಿ ಲೇಯರ್ ಗೊತ್ತಾಗಿದೆ ನಿಮ್ಗೆ, ದೊಡ್ಡ ವಿಷಯ ಏನಿಲ್ಲ ಅದರಲ್ಲಿ. ಮೋಸ್ಟ್ ಆಫ್ ದ ಕ್ವಶನ್ಸ್ ಬೇಸಿಕ್ಸ್ ಇಂದ ಆನ್ಸರ್ ಮಾಡಬಹುದು. ಎಕ್ಸಾಕ್ಟ್ಲಿ. ಮತ್ತೆ ಇದು ಹೀಗೆ ಮಾಡ್ಲಿಕ್ಕೆ ಆಯ್ತು ಯಾಕಂತ ಹೇಳಿದ್ರೆ ನಾವೆಲ್ಲ ಬೇಸಿಕ್ಸ್ ಇಂದ ಕವರ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ, ಎಲ್ಲ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಹಾಗೆ ನಿಮ್ಗೆ ಇದು ಸ್ವಲ್ಪ ಸುಲಭ ಆಯ್ತು. ಇಲ್ಲದ್ರೆ ಡಿ ಟಿ ಬೈ ಡಿ ಎಕ್ಸ್ ಅನ್ನು ಓಡೋಗ್ತೀರ. There might be number of good teachers all over India, students, but to come to your level, no, there are less teachers. Go with this pace, there are less teachers, that's for sure. And my pace is for the new students. Okay? It's not for the students who is repeating. You may feel it a bit slow. Okay? That's okay. That time you think about other things which can come. So you can make it fast by thinking, okay, can there be other type of question that can be said here? That mindset, let it go. That'll help you. Okay, done. Ciao. Next. ಇದು ಬರ್ದಾಯ್ತಾ ಬರೀರಿ ಅಷ್ಟರೊಳಗೆ 2020 ಅಲ್ಲಿ ಒಂದು ಮಾರ್ಕ್ ಕ್ವಶನ್ ಬಂದಿದೆ ವಿಚ್ ಇಸ್ ರಿಯಲಿ ಈಸಿ 2020 ಅಲ್ಲಿ ಇನ್ ಅ ಫರ್ನೆಸ್ ಎಷ್ಟಂತ ನೋಡಿ ಬಾಕಿಯವ್ರು ನೋಡಿ ಹೇಳಿ ನನಗೆ 2020 ಸೆಟ್ 2 ಅಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಬಂದಿದೆ ನೋಡೋಣ ನಾನು ನೋಡ್ತೀನಿ ಆಯ್ತಾ ಇದನ್ನ ನೀವೇ ಮಾಡಿ ಮಕ್ಕಳೇ ಇದು ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತದೆ ನಿಮ್ಗೆ ಏನು ದೊಡ್ಡ ವಿಷಯ ಏನಿಲ್ಲ 2020 ನಾನು ನೋಡ್ತೀನಿ 2020 ಮೆಕ್ಯಾನಿಕಲ್ ಸೆಟ್ 2 the brick wall. Let us go with the brick. ಇಲ್ವೇ ಇಲ್ಲ ಇದನ್ನು ಇನ್ನೊಮ್ಮೆ ನೋಡಬೇಕಾಗ್ತದೆ ಒಂದು ಮಾರ್ಕಿನ ಕ್ವಶನ್ ಹಾಗೆ ಏನು ಕಷ್ಟ ಇಲ್ಲ ಸೆಟ್ 2 ಅಲ್ಲಿ ಬಂದಿದೆ ದ ಮೆಷಿನ್ ಇದು ಬರ್ತದೆ ಯಾವ್ದು ಇದಕ್ಕೆ ಆನ್ಸರ್ ಯಾವ್ದು ಹೇಳಿ ನೋಡುವ the process that uses tapered horn to amplify the focus of mechanical engineering for machining of glass is ನೋಡಿ ಎಷ್ಟು ಸುಲಭ ಉಂಟು ನೋಡಿ ಎಲ್ಲ ಇದು ಕ್ವಶನ್ Question number is 45. Yes, students, solve this question fast. I will not say anything. You should be able to solve the answer. Question from 2020 set to marks 1. ಬಂತ ಆನ್ಸರ್ ಫಸ್ಟಿಗೆ ಸಾಲ್ವ್ ಮಾಡಿ ಮತ್ತೆ ಸಾಲ್ಯೂಷನ್ ಮಾಡಿ ಫಸ್ಟಿಗೆ ಸಾಲ್ವ್ ಮಾಡಿ ಆನ್ಸರ್ ಬರೆಯೋದು ಮತ್ತೆ ಮಾಡಿ write the question later students solve the question first What's the answer? 0.5. Let us see. Chances are there it is right. Okay. So question number 24. I'll see here. Correct answer. Super. Others. Answer is in fact 0.5. What you have to do? You have to write R. R is equal to R1 plus R2. That's it. Huh? Length is given, no? L2 is equal to L1 by 4. Okay. Then you can find L2. If you try to find using R, there are two unknowns here. So one is L1 and L2. We can reduce that, but still. Okay. Then again, we have to find out the Q. Q is given anyhow, heat flux. So Q is equal to, we can say delta T by R. Fine. Here R1 can be equal to, R1 can be equal to L1 by, yeah, area is same. Okay. L1 by Ka. K, I will let A is the same. Plus L2, instead of that, L1 by 4K2. I can write that. So I can say L1 by 1 by K1 plus 1 by 4K2. You get however you are comfortable, students. Okay, don't worry about that. So what you can write, Q is given. Okay, so here one of the trouble what happens here is, so even if you write 2500 here, you will have the trouble. L1 we do not know, right? K1 we know anyhow, 2.5 we know, but we do not know K2. Finding the K2 is trouble. So what you do? First find out L1. How do you find out L1? Q is the same, 2500 is equal to, we can write it as delta T, which is 1100 minus 700 divided by L by, divided by L1 into K1, right? K1 divided by L1. So L1 is don't know, so we can find out L1 using that zero point 0.4. So you get zero point 0.4 meters. Once you get L1, you can find out K. Easy. 0.5. Easy. Now write the question if you want, or you can skip that. Don't worry. I hope you got the way how to solve. That is very important. Next. In 2019 set 2, there is one question. See here. Now heat transfer, this topic, the questions are less. Okay. But the questions will come now. Sometimes more, sometimes less. Okay. So 2000, it is not heat transfer being less. Heat transfer, this topic being less. Okay. So let us go with 2019 mechanical engineering. And here, set 2, we have one dimension control F. Steady state. Steady. No. This is having a trouble in doing the control F. So it's a 1 mark question. It's easier to find out, is it not? Yeah. Can you tell me the question answer for this students? Want you can write this question also. 2019 set 2. 2019 set 2. So this is from 2019 set to 1 mark. How did you say that? Where is linearly? That's it. It is C. That has to strike. The area of the cylinder, where is linearly? And the, huh? See what is happening here? Yeah, area is in the denominator R, so it comes as log when you integrate. Is it not? Log of that, because dt by dx is equal to q by ka. You understand? Area changes with x. Area is a function of x. That's all. So when you integrate something which is function, you have to have a logarithmic, is it not? So dt is equal to q by k into dx by a of x. Something which is in the denominator has to go as log, right? And it is said a of x is linear. See, it's very important that it is linear. Linearly varying means some q into r, some a constant into r. It varies linearly. It has to come like that. Easy. So what you can write this question, students. ಆಯ್ತಲ್ಲ ಬರ್ತಾಯ್ತಲ್ಲ ಆಗ್ಲಿ ಆಗ್ಲಿ ಗಡಿಬಿಡಿ ಏನಿಲ್ಲ ಆಯ್ತಾ Agoy tayar kar do. Set. Next. Next one has come in 2019, set 1. Same question paper, but set 1 for 1 mark. This one. A slender rod. You can do it easily, students, nothing great. So, these questions are sure short. You have to get the answers. A1, A K1 plus K2. Everybody agrees? D. Okay, let us see. Question number 11. Others. D. D is the answer. What does it come? Want to put efforts in this? So let us look at it. So what is here? There is one rod. There is another rod here. Here, keep in mind there will be a negative mass. All of diameter, same diameter, right? So this is length L to form a composite rod of 2L, right? Composite rod of 2L, that is L plus L, right? The heat transfer in the radial direction and contact resistance are negligible. Effective. So this is K, this is K. So what is happening? Q is the same. Q is not Q1 plus Q2. Q is equal to delta T divided by minus delta T divided by area, sorry, delta T divided by L. Here you have K. Now, if we had used only one rod, okay, that is a different case. If you had the composite rod, what would be the composite rod? Composite rod Q is the same, is it not? Composite rod would be equal to minus delta T would be the same. K would be the same. Correct? Sorry. K1 and K2. This is K1, this is K2. I'm really sorry. K1 and K2. Identical dimension, but K1 and K2. Q is the same. What is the together R? R is equal to R1 plus R2. Is it not? What is R1? L by K1A. What is L2? L by K2A. Area is the same. Where L is 2L? Composite rod. Composite rod is 2L. Total. Correct. Read the question properly. So what will happen? Q, which is equal to the resistance L, is actually equal to 2L by K into A. K effective, right? Resistance, total resistance. Other things are same. Don't have to worry. So you can get. So this is K effective. So you have to get A cancels. L cancels. So you get 2 by K effective is equal to 1 by K1 plus 1 by K2. That is equal to K1 plus K2 divided by K1 K2 2 by K effective. So K effective is easy. Thinking is important. Done. Which time is it? No. Still 15 minutes is there. I thought only 4 questions we have done, and it is. But we have done challenging questions. These are good questions. Next. Okay. This has come in 2016 set 3. And the question 2016 set 3. Till then there was no questions on this. Heat generation was there. Oh, wait a minute. Yeah. So another question has come in 2018 set 1. 2018 set 1. There is a fantastic question. And it is of 2 marks. The question is starts with the plane slab, a plane slab. Yeah, this question. Yes, students, solve this. This deals with overall heat transfer coefficient. Uh-huh. Let us see. 33. Let us see here. 47 is it not? Let us see over here. Don't. Yeah, 33.50 to 34.30. See, where did you do mistake? Uh, 33.88. You get it, you get confidence. Simple. Good. No, no, do it, do it, do it. There is a person in Nitte who has got 9.89 CGPA. His name is Ishwar Kanduri. This time, information science. You know that person? Oh, how do they give that? No, no. Is it a relative grading for you or this much marks? No relative grading. Then how can you get that? Is it a relative grading? Do you get, say, for example, what is the point of this kind of grade point? I don't understand. The idea about relative grading is like this. Why do you do that? Then you are reducing the this one. I say set a very difficult question paper, get a Poisson distribution, and say above this particular one will get 10 CGPA. That is what is the main reason. And VTU, yeah, see, if it is autonomous, I think you should be doing that. Okay, whole of VTU, you can always have a Poisson distribution. Then you have to make it very tough. The person who should get 10 CGPA should get around 65 to 70 marks out of 100. So you should struggle like anything. And they should depends on a Poisson distribution. Just like it. But they're written. Chalo, done? Everybody got the answer? How many of you did not? Trishul got the answer.
I made a mistake, sir.
Please,
I'm
please.
correcting it.
Correct, correct. So when you get the answer, you get confidence. That's why I give you time. One more question I'll put. By then you solve this. Yeah. This is one question which has come in 2016 set 3. Can you solve that please? The previous one you solve first, then you come here. This has come in 2016 set 3. Okay, the previous one is solved. Solve the previous one, don't come here. Solve. Solve the previous one, don't come here. Until you solve the previous one, don't come here. ಇಲ್ಲಿ ಬರ್ಲಿಕ್ಕೆ ಕುಡ್ದು ಇದು ಆಮೇಲೆ ಕೊಡ್ತೇನೆ ಟೈಮ್ ಕೊಡ್ತೇನೆ ಬರಲಿ Hello, hello. யாரம்மா? யார் வேண்டும்? யார் வேண்டும்? இல்லம்மா, இல்லம்மா, அருண்ராஜ் அல்லம்மா, இது அருண்ராஜ் அல்ல, சாரி, ராங் நம்பர்மா. People from, because this number would have gone to a lot of other people, no? The அருண்ராஜா யாரப்பா இது பேசுறது? 67. ಬಾಕಿ ಆನ್ಸರ್ ಸಿಕ್ಕಿತಾ ಮುಂಚಿದ್ದು? 15. Correct. Dot. You see, when you do this, you get confidence, is it not? That's it. Tomorrow we'll go with radiation. Radiation is a simple one. Next we'll go with conduction. Tomorrow 1 plus 1 radiation, and day after tomorrow we'll start with conduction to the depth. Radiation in the sense radiation to the surface. Or we'll solve some more problems. What do you see? We'll solve some more problems tomorrow. So a lot of questions have come on this topic, and you'll get confidence by solving this. Yes. So I think our some of students did not get the answer for this. Is it not? We did not get. So here, what happens? The overall heat transfer coefficient. What has to be there? 1 by UA is equal to, what did we get here? We get 1 by HA, correct? It plus L by KA, right? Plus 1 by HA on the other side. But on the other side, it is not there. Here, it's directly given. So the overall resistance 1 by UA is equal to 1 by H, which is equal to 10, and 1 by L by K. L is given as 20 centimeter, which is 0.02 or zero point 0.2 divided by K, which is 2.5. So you get 1 by UA. So you get Q is equal to delta T divided by R, which is equal to, this is the resistance which is there, R. So this R, Q is equal to delta T by R, will give you 45 minus 25 divided by whatever R you have calculated here. Done. Once you do that, then here, what is the heat transfer here? Q is equal to HA. A is 1 we are taking, into delta T. Q is known, which we have calculated here. We have calculated Q here. That Q you substitute. Delta T we do not know. H we know. Delta T is H into H is 10. Delta T is 45 minus the T wall 1. Easy. Q is what? R is given as here zero point 0.1 plus zero point 0.2 by 2.5 is how much? 0. 0.8. Sorry, point how much is it? 0.2 by 2.5. 0.116. See how much is it? Hey, why am I got? So you'll get this zero point 0.2 by 0.2.5 is how much? You multiply that by 4. 0.18. This is 0.08. So it is 0.18. You put that here. So 45 minus 25 is 20 divided by 0.18. You get Q. You apply that Q here. 20 divided by 0.18. And H is known 10. TW1 you can take. Next one you have to do it. So we'll stop it here, students.